Oh, I'm on. Okay. Hi, this is Mrs. Murdock, and I wanted to go over the concept of gene mapping and how you can map the position of a gene. Here, I have some chromosomes here on the table. Map the position of a gene based on its crossover frequency, right? So if you're looking at two genes for two separate traits, first let's just look at this. Let's just look at this. Just this one here, okay? So you remember meiosis. You remember that in prophase 1, something happens called crossover, yes? So what I did with these beads is I made the two different genes on two different locations on the genes, right? So this is a homologous pair. So perhaps this is the gene for, I don't know, eye color, and this is the gene for hair color, whatever. They're for different traits. And they're located at something called a locus. The locus on a chromosome is the position of the gene. That's where the strand of DNA is that codes for whatever protein that gives you that trait. And sometimes you'll see the word loci or loci, I don't know how they pronounce it. Loci is just the plural for locus, right? So here are some loci for positions for two genes on these chromosomes. Now think about crossing over. Crossing over is normal. We want crossover to happen. We want there to be diversity, right? So if crossover happens like this between these two, then these guys will change position, won't they? And they will no longer, like the blue will no longer be stuck to the yellow. It'll be stuck to this one over here, right? Say these are both dominant and these are both recessive. You can exchange them by this crossover method. And there are lots of positions. In this case, there's pretty much, you know, there's at least 4 different positions there for those genes to change positions and wind up giving you recombinant offspring. Remember recombinant offspring, right? Okay, so the further the genes are from each other, the higher the crossover frequency is going to be. Now the way you calculate crossover frequency, I don't have this written out here, but I'll do that on the board later. But crossover frequency is calculated when you have the numbers of offspring, like the 4th cross that you did with the flies, where you had like 400 double dominants and 400 double recessives, and then like 18 of each of the recombinant DNA where those dominant and recessive traits were mixed up because they were crossover between each other. That's the only way to get recombinant creatures. So then you add up the total of offspring, those two middle numbers of offspring, the two low numbers. Like there's 18 flies with the black body and the vestigial wings, and then there's 18 flies with the normal body and normal, and you put those flies in the center. Those are your recombinant offspring, and you divide those offspring by the total number to get a percentage. That percentage then just becomes your map units. Okay, but now let's take another look at this. What if the positions of the chromosomes was different? Well, here, just use these. What if the positions of the chromosomes was really close? Like what if it was here and here? Those two locations were where two different genes were on both of these chromosomes. Then the only way crossover can happen is if the chiasma happens right there. There's only one place where they could cross over and successfully exchange each other's positions, right? So that means that the crossover frequency is going to be much lower because they're much more likely to not cross over, right? Or to be just inherited together. If they're inherited like that, they're still going to be inherited together. So that explains the further they are apart, the further the genes are from each other, the more likely they are to cross over and exchange places and give you recombinant DNA. The closer they are to each other, the less likely they are to exchange places during crossover and give you recombinant animals, right? So crossover frequency is directly related to the distance between loci of two different genes on a chromosome. And that's it, and I hope that was helpful.